Welcome to another project. This one's fortunately nearing completion. This is the fork seals, the fork leg reconditioning job I'm doing on the VTX1300 behind me. So this bike's got about 37,000 miles on it, and the clear coat was coming off. There was pitting underneath the clear coat. Water and corrosion had gotten under the clear coat and started to corrode the aluminum. So fork seals were leaking. I had to do the fork seals anyway, so I figured I'd refinish these while I had it apart. And I want to show you how I did it. So the first step is I used a very simple over-the-counter paint remover. Just stripped off all the old clear coat, and then I went at it with some quadruple zero steel wool and some chrome polish. I was actually looking for Noxon, but I can't seem to find Noxon anymore. So this seemed to work, and that got rid of the pitting and the corrosion. Then I had to polish it up to a high lustre because, of course, the quadruple zero steel wool left it a bit grainy. So I went at it with a medium cut Meguiar's polishing compound and a disc on my drill, and it came up really nice. And then I had to figure out a way to protect it and get this clear coat finish back to factory finish essentially. And I've used this product before. This is it's a Max 2K. It's called Clear Glamour. It's a clear coat. And it's a two-part hardener in here. So there's actually a vessel inside this can. This is the puncture mechanism. You depress this, puncture the vessel inside, the two chemicals mix, and then you got about 48 hours to use this or consume this product completely before it all hardens in the can. And this makes a really durable finish. I used that product on my Honda Hawk about eight years ago, and it's held up really well. So I think this is going to be a nice addition to this bike and bring it back to near show quality. So now we're going to reassemble these forks, and I want to show you how these go back together. So let me get my bits all together and I'll be right back. So we got the fork leg we talked about earlier. This is where the axle goes through, the wheel and tire get mounted, the fender, and then on the other side you got the brake caliper. That's the bottom of the fork in a conventional. These are conventional forks. These forks have been used on many Hondas throughout the years. These are 41 millimeter in diameter conventional forks. No flow control, no adjustability. And we'll see that in a second. And then of course you've got the fork tube with your two bushings, your bottom bushing and your top bushing. These are consumable items. This copper band will wear away on both, and they can be replaced. They're actually in really good shape still on this bike, so we're going to reuse them. And then inside we've got the damper tube. So this is basically a piston, and this is basically a piston ring. This slides in and out of the fork tube, and it creates your flow control. And this hole here is part of your flow control, and the hole inside here, the fluid goes back and forth, and there's very little control. I mean, they designed this for the weight of the bike, and the style of the bike, and the performance of the bike based on the holes. And the only adjustability here is the weight of the fork oil. So Honda calls for 20 weight in this bike, which is pretty thick actually, and that slows down the movement of the rebound of the spring and so forth. So you can adjust that by changing the weight of the oil, but in this case we're going to use what Honda recommends. We're going to go with 20 weight. This is the top out spring. So this actually, when the suspension fully extends, as if you were, if you jump the bike, for example, and the front wheel would extend all the way, this is what catches it so it doesn't bottom out, or top out I should say, not bottom out. So the way this gets assembled, so at the very bottom of the fork leg there's a screw, and we should always replace this screw because when they strip, boy they're a bastard to get out. So I always use new ones of these and a new crush washer, because this crush washer is part of the sealing containment vessel of the oil. It sits in the fork, and it sits at the very bottom, so you got a lot of static pressure of oil pushing against it. And that basically just screws in here once this is assembled. There's also this little cup that goes here that the screw goes through. This is like a locating cup once it goes inside, and you'll see that in a second. So the first step is we have to slide our damper assembly into the fork tube and get it to protrude out the bottom, like so. Then we put our locating cup on the bottom, and then we assemble that into the fork leg. Now before I do that, I'm going to coat these bushings in oil so that when they go in there, they go in nice and smooth, and we don't get any binding and scoring. So I got a nice coat of oil in there, and I've got dribbled some oil down in there where the mating surface is. So now we're going to go ahead and slide these two pieces together. And it bottoms out. Now I have to make sure that the screw starts. So this is a 6mm. I have an extension Allen without a ball end. Do not use a ball end. To remove these, you can break the ball and you can actually strip these. So now we're going to make sure we can thread this in place. Yep, and we'll tighten that in a second. What we need to do now is get this top bushing down in here. Whoops. And the bottom bushing went all the way in, and we can slide her up and down, and this is the whole stroke. This is the whole stroke of the fork assembly. And you can feel that top out spring right there. So now we need to get this top bushing down in there, and that's going to take some encouragement using a fork oil seal driver. So basically this, make sure it lines up nice and centered, and then we'll put this washer on top, which is the way the thing normally is assembled. And the curvature part goes up top. There's a flat part of the washer that goes down right against that bushing. Make sure it's nice, and then we take our, again, these are 41mm forks. This is a 41mm fork driver, and we just tap it, make sure it's going. I can see that it's started, and you'll actually hear the sound change when you bottom out. There, did you hear that? So now we know that that's bottomed out. I'm just going to tip it over to take that washer off and make sure that it's level with the surface. And it is. We're good. So that's that. Now we can put the fork seals in, the dust boot in. We can tighten the damper rod bolt, check the oil level, which we'll get to in a second, then put the spring in and reassemble. So what I'm going to do now is prepare for the fork seal installation, which this tube has to be absolutely clean. You don't want any debris getting in between the fork seal and the fork tube. And then the very end of this, these can be sharp at the tip. So I put a piece of electrical tape around here so that the seal will go over without cutting it. So let me take care of that, and I'll be right back, and I'll show you how these seals go on. Alright, I'm at the point where I'm going to tighten this bolt, the 6mm Allen bolt with the crush washer, in the bottom of that fork leg up into the dampening rod. And it's 14 foot-pounds of torque. Got my torque wrench and my extended Allen wrench. And there's nothing to prevent the dampening rod from turning. So we just hope that it doesn't, right? And if it does, something that would help is if you reassemble the spring and put the cap on, compress the spring can actually keep it from rotating. I've had pretty good luck putting these together, especially when you use new bolts and you clean out the threads from in the bottom of the damping rod, that it doesn't turn, and you get a good bite at 14 foot-pounds, and she crushes the crush washer, and everybody's happy. Let's see what happens here. When you remove these, some folks say to use blue Loctite on these. I completely disagree with that. If you Loctite this bolt in, it's going to be very difficult to get it out, and you're going to have to impact them out, and then you have a chance that damping rod is going to spin, and you could cause damage. And then I've seen people use broom handle sticks and pressure to try and keep the thing from turning. They do make a special tool for it, and of course every bike is different. Every bike requires a different tool. So if you can do it without it, that's great, and that's why I don't use Loctite when I reassemble these, and I always use new bolts. So let's see if we have luck. I'm going to bring you down here so you can see this. In 1 second. So here we are. I'm just simply holding the assembly. Got my torque wrench set to 14 foot-pounds, sorry. And let's see what we can get. Yep, there we go. Okay, it's grabbing. I'm just going to reposition here so I can keep this thing from rotating with my arm. and it's not spinning. That's good. I can feel the crush washer crushing. There we go. 14 inch-pounds, no troubles. So now our damper rod is permanently secured. The crush washer is crushed. I felt it, and our bushing is in. Both bushings are in. Let me put you back up top there so we can do the fork seals next. All right, next up is fork seals. So the new Honda fork seals, there's two sides to these. The side with all the writing on it and all the markings, not sure you can see that, goes up. The other side has no markings on it, that goes down. And this is your fluid containment, and these are consumable. They do make a, I think they call it a seal saver, or I saw it at Cycle Gear, and it's a little plastic device that you run around the inside of this, and it's got a little fine piece of plastic that's supposed to clean up the fork seals. I don't know if it works or not. All right, so I've got one here pre-soaking in some fork oil. Again, the key to this is getting everything nice and lubed up so you don't pinch anything. And I've got my electrical tape. It's blue, but it is electrical tape on the tip so we don't cut anything. And I'm going to just slide this guy down. Being very careful. Again, it's very important that this is nice and clean. You don't want to pick up any debris in there. And we get the fork seal in there. And again, we go back to our fork seal driver, 41 millimeter in this case. We want to make sure it's gone in nice and even. And what you're looking for, there's that satisfying thump. You're at the bottom. You don't want to do it too much. Catching on my tape here. Yeah. You want to see there's a lip in there that this C-clip goes in, and you want to make sure that that's exposed enough to grab the fork seal. And that's basically the next step here, is to put the C-clip in, which is actually what holds the fork seal in place. And let's see, I'm just going to use the tip of my Allen wrench here because I didn't leave a screwdriver out. I'm just going to push this down until you hear that satisfying click. There's that. Okay, now is the dust boot. This is self-explanatory. The funnel shape goes up to repel any water. I'm just going to give this a quick coat of oil with my one hand here. Just got to make sure the inside is coated so we don't tear it up. And the outside is coated so that it's nice and goes in nice and easy. Same thing. I leave my tape up there so we don't damage it. And a lot of times you can just push these down by hand, just like that. You don't need the fork seal driver. You can just squeeze them down, and now we're good. This fork is assembled. Now we need to put oil in it. And here's the big misnomer about oil. They talk about fork oil level. Every manufacturer has a spec. There's usually a quantity spec, and then there's usually a height spec. And the confusing part is people think it's the level of the oil. It's actually not. It's the level of the air. It's the gap of the air before you reach the oil. And in this case, for this VTX1300C, it is 125 millimeters of air gap. So that is with this fork completely collapsed, no spring in it. The air gap should be from here, measuring down 125 millimeters where the oil starts. So let me get my special tool to measure that. I'm going to dump some oil in here, and you'll see what that looks like. So the Honda shop manual tells me that the quantity is 15.8 fluid ounces of fluid. So it's about half a liter is what we're going to start with. And that's a real rough adjustment. We need to do that gap measurement process. So I'm going to put about half of this bottle in this fork. Now we got to prime this thing. So remember, that damper rod is completely empty. We need to get it fluid flowing in there, and we should be able to feel the damping effect as the air bubbles come out of it. So we're going to just, there we go. And this is, we're using 20 weight, which is what Race Tech calls for. Honda doesn't actually call for, I'm just looking for a rag here. Honda doesn't actually call for a weight. They say to use their branded stuff. but Race Tech says to use 20 weight. And I believe it. This is a heavy bike, and there's very little flow control in here, no adjustability of these forks. So 20 weight for a big heavy cruiser like this sounds right to me. You gotta watch, sometimes these, when they, Moto Guzzi's famous for this, they'll use, one fork leg will be for compression dampening and the other would be for rebound dampening. That's not the case here. These forks are identical. They do both compression dampening and rebound dampening on each leg. So you just got to work the air out. Once you hear all the air bubbles come out, now you can take your measurement. And again, the measurement's taken with this thing bottomed all the way out. And this is my tool for measuring that air gap. So this ring here sits on the very top of the fork tube, and this length of tube is exactly 125 millimeters. It's adjustable with the set screw. One of the troubles with this, they have graduations on here in millimeters, and I'm at the age where I can't read it anymore, but yeah, 125. So I just saw that. You have to have good lighting, and what you do is you basically just take this and you stick it down there until it's flush, and then you pull up on this syringe until we get some fluid out. And I should have enough in there to get some fluid going. I'm going to need 2 hands. I need 3 hands. Yep, we got some fluid coming out, and now what we're basically doing is we got to make sure this is nice and level. And once we hear air, we're at that 125 millimeter level. I guess I put a little more in. Oh, there we go. So just like when you hit the bottom of a straw on a soda. So here's the amount that I overfilled it. We know now that the amount is exactly at 125 millimeters. So it takes the guesswork out of it. It's a great tool. I use it all the time. All right, now we need to reassemble the fork. The spring. This is a progressive rate spring. Notice it's tightly wound at the top and not at the bottom. It's a progressive rate spring. And on top of the spring, this is the what offers our spring compression or compression forces. This is basically how Honda tunes the suspension. These can be longer or shorter depending on the needs. So all of this has to go back in. And I'm probably going to have to move to the floor to do this because I'm going to have to put quite a bit of tension on the top of this cap to get the spring compressed. So let's see if I can move the camera so that you can see that. Here we are on the floor. We're going to put the spring in. We're going to put this preload spacer in. That's the word I was looking for in my head in the earlier segment, preload spacer. This is actually what gives us our spring preload, our proper sag for the weight of the bike and the weight of the rider. Honda has determined that this length is the ideal for this particular bike and this particular average rider. The only way to adjust the preload, spring preload, is to change the length of this tube. And in this case, it's just really not plausible. It's an inexpensive motorcycle and it's a very simple fork. If you were converting these to a race type of setup, or if you wanted more adjustability, Race Tech does sell a bunch of components to make these adjustable, tune them, and adjust the preload length. Some bikes actually come, this is the cap, and it's just a fixed cap. Some bikes have adjustability here. You can change the length of the internals to add or subtract preload, but not in this case. You'll see that in some of my other videos. So the first step here, now, so we've got the oil level set at 125 millimeters air gap, and if I just drop the spring in here, the oil is just going to overflow. So we actually have to, again, we need 3 hands here. So I have to extend this fork tube as far as it'll go. And I'm surprised at how short the stroke is on this bike. There's really not a lot of travel in the suspension. And we're going to put the spring in. And it doesn't really matter. I mentioned earlier that this is a progressive rate spring. On the right side here, on my right side, is the tightly wound coil, and then on the bottom is the more loosely wound coil. Doesn't matter which way this goes in. Some folks like to put them in heavy side down to reduce the unsprung weights, and that's probably the best way to do it. We're going to do that. Put the spring in, and you want to do it gently so you don't splash that oil out. And then there's a washer that sits on top of the spring, between the spring and the preload spacer, which I have to grab here. Make sure that sits flat. And then our preload spacer. Now, this is the tricky part. We have to compress 100% of this spring preload to get the cap started to screw. And there's no easy way to do this. You basically just have to enable beast mode and go at it. So I always put a little bit of oil on the threads so that they catch easier, a little bit of oil down in the female portion of the threads. And what I do, and again, I can't let this fork tube go because it'll drop down and the oil will come out because the spring is now in there. What I do is I just cup this in my palm. You have to be very careful because this can pivot back and forth, so you have to stabilize it. It's a very fine pitch thread, so you have to get it caught in the right spot, and just basically use all your upper body force, compressing the spring, and because this hex, 17mm hex, is going to be pressed into your palm, you won't really be able to turn it, but you can turn the fork tube, and that's how we get this done. So let's see if we can get this done in the first shot here. Okay, just be real careful. This is only grabbing on by like a hairline thread, so this could release some of it. So be very careful here. And I don't have enough friction to hold the fork tube. Grab a rag here. Nope. Nope, we're not catching the threads right. I'm going to have to do this again. Try again. Actually, I'm going to put some more oil on this. There we go. Oh, shit. I think that's good. Yep, we got it started. And now we just get it to the point where we pass that O-ring. And that's that. So what I do to tighten this cap to the proper torque spec is I wait until it's assembled in the bike so that the triple tree is clamping on the outer tube. Otherwise you'd have to clamp this in a vise, and I don't have the jig to clamp this in a vise and keep it protected. You don't want to scratch this up. So whenever I do forks, I always do, the very first thing before I disassemble the bike is I loosen the cap so that I don't have to put this in a vise, and then on the back end, when I reassemble, this is the last thing I do is tighten this top clap so that the triple tree holds in place. So now we are completely done with this fork, and it's ready to go back in the bike. So that's it for this video. I'm not going to bore you with the details of reassembling the axle and the wheel and the brakes. This bike is almost ready to go down the road, and next time we're going to be doing this exact same thing, only on inverted Ducati forks from the Monster, which will be a little bit more complicated because they're inverted. Those are also mount adjustable, so we'll see what's inside those in the next video.